Hi guys, I'm Dr. and welcome to my machine learning series, and today we will be discussing about decision tree. You must have listened to this about decision tree, random forest, and they both are related and they form a strong concept in machine learning field. So today we will be discussing about decision tree, and random forest is nothing but the ensemble. Ensemble means a collection of the decision tree. We will be learning that in future, and also we will be learning more about decision tree in future. So here today is only a quick start about the decision tree. So it's a very simple concept, very easy concept. You don't have to be a data scientist to understand what a decision tree is. You don't even have to be a developer to understand what a decision tree is. But of course, you have to be a human. Uh, so let's get started. The question arises: what is a decision tree? Decision tree is something which help in taking some decision. For example, I want to know, should I drink a coffee? There would be multiple factors which come in. Is it raining? No. Is it a cool environment? Maybe it's hot, so don't want coffee. So there are various things which a human mind thinks when taking a particular decision. So similarly, a decision might be simply should I wear a jeans today? Then am I going out, or would I be fine in pajamas? So there are various other decisions which are taken, and and before taking a decision, there are various conditions which are checked on various conditions which are checked to take a particular decision. So the decision tree can be said as a human how the human mind thinks. It's in a sequence of conditions. If those conditions decide the flow of our thought, and we reach to the final decision on the conclusion. Okay, that is same with the decision tree. We will look how. So, for example, but before diving into decision tree, let's look into the some terminologies of a decision tree. In the decision tree is very similar to the trees. If there are any developers watching me, then decision tree is very similar to the trees which we study in the data structure. These are the node, and node 1, node 2, node 3, and nodes are basically connected with edges. So it would be edge 1, edge 2, and so on. The last nodes are known as the leaf nodes, and because they don't have any children, children means they don't have any node connected. So these are known as leaf nodes. And any the node is known as a root node. I know it sounds weird, but the top node is known as a root node, and the bottom node is known as a leaf node because it don't have any branches or any edges coming out of the node. Okay, the two here, one is a parent of two and three, and two is a child of one. Uh, these are the basic terminologies of decision tree, and let's dive into the decision tree. Okay. Okay. Yeah. Okay. The first question which comes to means, let's try to answer this question. Should I go out? How in our mind we create a decision tree. So first, before going out, we basically check how is the outlook today. Means how is the weather today. Outlook means weather. How is the weather today? So is it sunny, is it rainy, or is it overcast? If it's, for example, sunny, then we will check, is it humid today, or is it fine, or is it windy? If it's humid, then we further think that how humid it is, and if it's windy, how windy it is. So depending upon various conditions, we thought, and we reached to the conclusion that yeah, I should go out today. No, it's too sunny, or it's too humid today, I won't go out, or it's too windy today, I won't go out, and so on and so forth. We come to a decision. So this is one of the example of the decision tree, and we will move through it. We will have a look into it. So before taking a look, and we will also see how we can map it to the into the model building part and how it is used. Okay, here basically, if you will see, here is one of the feature. Feature, I would say, here is one of the predictor, right? Predictor in taking the final decision. So the outlook is one of the predictor, wind is one of the predictor, humidity is one of the predictors. So these values are also known as predictors. Right. Uh, Predictors. Okay, it's a T. I know my handwriting is very bad, and no, okay. So it's a predictor, and these outlook, humidity, and windy all are predictors. And over the predictor, we apply some condition, like this is one of the condition. To better understand, this is one of the condition. We put a condition of less than 75 or greater than 75 on humidity. Similarly, we put a condition of positive or negative on windy. We put a categorical, we compare it to the categorical value, sunny, rainy, overcasting, to the outlook. So basically these are various conditions which have been applied over the predictors, and depending upon the result of the condition we are moving down the tree, and moving down the tree we reach the leaf node, and actually leaf node is nothing but the conclusion, our decision, we should go out or we should not go out. Okay, so this is how decision tree works. This is a very, very simple decision tree. In reality, it will be very, very complex decision tree. If I will, so basically, it have a three predictor. Predictor is also known as features in data science. For example, here I would be given a data set about the weather condition, and in the weather condition there would be only three columns according to this decision tree. One would be the outlook, other would be the humidity, the third would be the windy. Depending upon the outlook value, here for example, sunny outlook value, humidity 100, windy yes, I would have some predictions over there. This prediction, if the model is trained, this prediction will be taken by the decision tree, and it will depending upon this. If it's sunny and if it's greater than 100, we know that we are not going out. So the prediction would be no. Similarly, if this would be sunny, 50, windy, yes, yeah, I would be going out. If it's windy, sorry, it's rainy, and it doesn't matter, and it's windy, yes, then I won't go out. So this is a prediction column which has been predicted by our model. This would be the various inputs which have been given to our model, and the model gives the output as a prediction. So this is the model. This is actually a trained model, and this model takes only three features or three predictors and input. This is a very simple model. I repeat, in reality, we could have 50, 100, 150 predictors, and this model, this precision tree could be very, very complex, and it would be very complex, seriously. Okay, let's move forward. Yeah, there is one term which has been defined here, that is a maximum depth, where basically maximum depth says that how deep is the tree. If we basically take a level, this is level 0, this is level 1, this is level 2, so the maximum depth is 2 in this case. And now we can, while creating a decision tree in Python, we can limit the maximum depth. Also, if you will see then that, okay, yeah. Okay, great. So this is a maximum depth which we can predict while creating the creating in the Python. Okay, so let's further move to the advantages. Before moving to the advantages, let me make clear one more fact. And okay, 9 minutes have gone by. So let me make one more fact very clear. Also, did you wonder? Basically, this is also. Did you wonder why we took Outlook first, and after that we check the humidity? Why didn't we check the humidity first or the windy first? Basically, the predictors were, have weights associated with them, and the predictors coming early in the decision tree or coming at the top of the decision tree actually have more weight. So if I assign w1 to it, w2 to it, and w3 to it, then I can easily say w1 is greater than w2, and w1 is also greater than w3. So actually predictors have weight assigned to them, and the predictors coming at the top of the decision tree actually have a more weightage or relatively more important than the predictors coming at the bottom of the decision tree. So basically, This is here I have also shown that we divided it into multiple. Let's leave out that fact. We will put it for the future in the future session. Sorry for this. Okay. So yeah, and how the predictors are decided, we will move, looking into the future sessions. As we are running out of time now, then we will move further and towards the conclusion of this lecture. Let's keep it short and simple. Then we will move to the more complex lecture. In the next lecture will be more complex, and so on and so forth, and will be in more depth. Okay, let's move forward. Advantages over other models. The first is that it can work well on nonlinear data. It doesn't matter that my weather data was something like this, or for example, uh, uh, so it does not matter my data is linear or is it non-linear. So it works well on the non-linear data. It is interpretable. I know that I am going out today, then I know what are the various predictors which have participated in prediction of my going out. I also know that what are the deciding factors and what weightage they have in my final decision. Important. So this is the so basically interpretability, readability, presentability of this model is very fine grained or very clear. So this is a major advantage over the other models. For in linear regression, we have to go and check out the weights to find out what are the various weights of the predictors which are responsible for my this decision. But here it is very simple and very intuitive to a non-developer. You can easily show them how your model is working. Okay, so there is one more concept of regression with the decision tree. We will quickly look into it. Basically, it sometimes happens that a single regression model is not enough to calculate to predict the behavior. For example, in this case, this is a basically stress and strain graph. I have taken it from the physics, so don't go and study it. Basically, it says two things: elastic region and the plastic region. So if we keep on increasing the strain, if we keep on the stress within the element increasing, after a certain point of time, it enters the plastic region and it starts changing into its shape. That is a plastic region. And where it is not changing its shape, that is a elastic region. So this is a stress it can handle. So until this point, if I'm modeling this part, I know that this is a pretty straight line, and if I'm modeling this part, I know this is not a pretty straight line, but can be approximated to a straight line. Then straight line, for example, but the two straight lines are very different. So the model, if I take a simple linear regression model, the model M1 will be different from the model M2, right? And I can't say that no, I will take only a single straight line to predict this model. Then I would be very much deviant from the actual results which would be there, and especially on this yield strength. Okay. So actually, I know that there are two models which actually represent this graph or this type of data, and approximating it to a single model will be one of the biggest error I would create in life and give it to the client. Then I would be creating one of the biggest error blunder of my life. So what happens is that I would take a decision tree and I would create a decision tree and I will say, okay, decision tree, tell me, take in the data and using the values of the various predictors, find out that is this element currently in an elastic range or it is in a plastic range. If it's in a elastic range, the decision tree says that it's in the elastic range, I will use model M1. It says no, it's in a plastic range, I will use model M2. And if it says it's in a elastic range, I will again use a model M1. And if it's in plastic range, I will say it's a model M2. So this is how decision tree can be used to predict the various region of the curve, and over the a different region of the curve, I can use actually different models to find out the exact behavior of the curve. So I can replicate exactly the exact behavior of the curve. So this is known as a regression with decision tree. Python code is very simple for the starters. Just create a object, decision tree classifiers, and everything is over. There is little complexity, not much. That here it will take all the default values for all the parameters, but we can always customize it to the depth, number of leaf nodes, what would be the number of elements in the leaf node and so on and so forth. But we will hold on, we will study about it later. So no hurry. Okay, like my channel, comment if you have any question, or if you like it, comment, and do subscribe, because in future we are going deeper and deeper into decision tree. Do subscribe the channel. Thanks a lot. Thanks a lot. Bye.